Hello, good morning, friends. Welcome to this session of transformer technology. Today we will be discussing on partial discharge test, why it is so important for more so for a transformer, like what are its advantages if we do this test, and so on. We'll go in detail in this session. But before starting, as usual, hope you have seen our other videos about our factory where we told who we are. Like we 3S Eco Power Solutions is a transformer manufacturing company with very good quality standards set up in place, and we deliver very good quality products of transformers like transformers and packet substations. To know more about details, you can see our website as well. And yeah, let's go into the session. Let's begin the session of partial discharges. Partial discharges, what are they? And many of you might have heard the term partial discharge. Partial discharge very often is mentioned in transformer specifications, or I'm restricting this only to the transformers, not to the other electrical items like cables or any other thing which gets affected because of partial discharges. I'm limiting only to the transformers, but yes, more or less the theory remains the same. You can extend it once you are comfortable with this theory. And more importantly, like other videos, here also I'm just limiting the fundamentals of the subject, that's all. No high level technical jargon which will confuse you. It is just like for beginners, for students, for engineer trainees, where they will try to understand the concept. It's simple like that. Yeah, once you are thorough in this, then we can go to the next level. But first, the fundamentals of partial discharge. Now, what is a partial discharge? There are so many definitions floating around, and you might have read even in or learned in your college days, university or somewhere. But let us limit today's discussion to the definition mentioned in ASTM, that is American Society for Testing and Materials. Now, what are these partial discharges? According to that ASTM definition, it is nothing but it is a localized discharges. The name discharge itself is there. It is a localized discharges because of transient ionization of the insulation system whenever there is a variation in voltage levels. Or yes, the details I will be telling in further, but this is broadly the definition, and the exact definition you are viewing on your screen. So this is what is a partial discharge. Yes, partial discharges. Now we have seen the definition. So after definition, let us understand. Let us break this session into what is a partial discharge, which we have already seen in the definition. Now, where it is happening, where it may happen, why it will happen, how to control, what will happen if we are not controlling. Let us understand these concepts. Now, going forward, partial discharges, where this can occur. Partial discharges can occur in maybe because of first and fundamental, I feel like, is like if your design is not proper, then partial discharges may occur. Or if there is a high electrical voltage stress across the insulation system, or maybe wherever there are brazing or sharp edges which is not properly ground, these things will increase the voltage stress along that surface of the sharp edges, and partial discharges may occur. Improper insulation or processing of insulation. You have to process the insulation of the transformer, you know very well. So if you are not processing the insulation, partial discharges may occur. Even if it is a dry type, you have to give the proper curing time for settling in the resin system, and if it is oil type, you have to check the oil BDV. Low BDV may again trigger insulation collapse. So these are areas where partial discharges may occur. Yeah, now we have seen where partial discharges may occur in a transformer. Now let us see how we can contain the partial discharges. If it is an oil filled transformer or even the dry type transformers, the insulation of the conductor is more important. First of all, you should understand, or you should ensure that there are no voids on the insulation of the conductor. Similarly with interlayer insulation as well. If the interlayer insulation is having many papers, then again ensure that there is no void. How? If it is an oil filled transformer, what it is like, you do proper oven cycling, and after that you fill oil preferably under vacuum, and give some settling time so that oil is absorbed in all places, and no voids or air bubbles. So this is one important criteria. Even if you are filling oil, ensure it's properly done. And for dry type transformers, if it is a vacuum impregnation or casting process, ensure again the settling time of the resin. You should give proper time, enough time, so that resin is absorbed in all places and there are no voids. Whenever there is a void, what happens is like the void becomes a dielectric space, and the either side of the conductors become a parallel plate capacitor. So then the insulation becomes a capacitor like thing, and there will be again local ionizations because of these voids. Now what else, like if it is oil filled transformer, ensure oil is having good dielectric strength. So these are certain points, minimum points, where we have to ensure, like because basically again why ion partial discharges occur, because if there is a space where there is no what do you call, nothing is there, like a void, what happens is like either side of the void or the space becomes like a capaciting thing, like a parallel plate capacitor. So once there is a capacitance, then there will be a discharge as well. Whenever a cycle is going up and down, there will be discharges. So once the discharges are there, slowly what happens is like it will wear out the insulation because of ionization emissions. So this is a simple concept. So avoid voids, simple. We have seen what a partial discharge is. We understood its definition. Then we discussed where it will occur and how to contain. Now here let us understand now what is the significance of partial discharge in an electrical item, more so in a transformer. As I clearly specified, this session is only on transformer. So what is the significance of partial discharge in a transformer? Transformers, like if whenever there is a partial discharge, as we just because of local discharges of ionization, what is getting ionized? The insulation system is getting ionized. Why it is getting ionized? Because there are some voltages occurring in the transformer. Transformer itself is subjected to voltages. If the voltage stress is more than the capability or the capacity of the insulation system, the local ionization takes place because of the gaps or voids. Now once it is happening, slowly the insulation system will wear out. This wearing out of the insulation system is more if the partial discharges are more. That means if the transformer insulation system is not properly designed or properly cured, or the transformer is not manufactured properly, this partial discharges are bound to happen. And actually the life of a transformer in general terms is 25 years. Now the insulation system will get damaged because of partial discharges, and if partial discharges are more, the damage will be faster, and the transformer may not survive its lifetime. So basically it is damaging the insulation system, thereby the failures may occur in a transformer. So this is the significance of partial discharges in a transformer. Now, in order to verify the quality of manufacturing of a transformer, standards like IEC and IA specified partial discharges test. Actually these tests are not the routine tests, these are like a special test, or more like a diagnostic test. These things, this test is really good to understand the adequacy of the insulation system, or how the insulation system is performing over a period of time. So this is basically a diagnostic test. Now for dry type transformers, like it can tell how the casting is there, whether there are any voids or gaps while casting and all these things. We can easily find out by doing this test. And this test basically is not like other tests like an impulse test or a short circuit test where people say transformer has passed the test or transformer has failed the test. No, this is not a pass and fail test. This is very clear diagnostic test where the partial discharges are measured and whether the partial discharges are within the acceptable limits specified by the customer. It is between the customer and the manufacturer. Both has to decide what are the acceptable partial discharges. Now in long run, once the transformer, even if it is well within the limits at the factory test, and if you are taking this transformer to the field, it is always advisable to measure the partial discharges at a particular frequency and compare the partial discharge values with the previous readings always. You can put a matrix and see how the results are performing. If they are consistent, that means the insulation system is very well and good, and if it is varying, then the variation is also very high, the deviation is going too much, then there may be a reason to worry. That's all. Let us sum it up what we learned about partial discharges, and whatever I have mentioned, it's already I just simplified and abridged into this last slide of mine. Like you can see what are the partial discharges. Yeah, go through please. And if you have any further clarifications or any if you need any further details about partial discharges, you can always send a mail to us mentioned here, or you can follow our company 3S EcoPower on LinkedIn, where we'll be posting our updates regularly. You can follow us there at the link, or you can follow my LinkedIn profile like I'm mentioning here. I will also be posting some good details. Or if at all you want to share this, or if you want to have a rerun of what I have said today, you can always subscribe to the channel and see as many times as you want. This is all for the education thing. You can share to your friends or any other students who wants to learn something on transformer technologies. Please share this. And for all the prospective customers who wants to find a transformer or who wants to buy a transformer, yes, they can very well send the inquiries to the mentioned email address here. We will be ready to help you with the proper solution at a reasonable price and a high quality. We make transformers up to 36 kV, 16 MVA at our factory for oil field transformers, and we make dry type transformers as well. Our factory is in Tada, Andhra Pradesh, and we are 3SI EcoPower, and we are nearer to Chennai, India. With this, I am concluding this session, but we will be joining with another exciting topic in our next session. Till then, have a nice time. Goodbye. Namaste.